Okay. So, once you have this good to go, just type a G in the chat so that I know, because I need to make sure everyone is ready and good to go. Where's my chat? Oh, there it is. So just waiting for around 3 more people, and then we will get started. We're just waiting on one more person, I believe. But I think overall, I think we're good to go. Okay. All right. So 4.5, today and tomorrow's lessons are actually going to be fairly short, so we might be ending early today as a result. Um, but we'll see. We'll see how it goes. Let's see how well you guys do with the angles part of this unit. I know Mercel's been really excited for this. He loves angles. So yeah, let's do this. So 4.5. So we're talking about basic angle theorems, angles in triangles and quadrilaterals. These are things. Some of these you've heard from like middle school as well, right? Previous grades. So we're just kind of reviewing. This whole lesson is pretty much review of almost everything that has to do with angles, and then we'll jump into new stuff in a bit. So 4.5, the sides of a polygon are named by their endpoints. Number 2, angles are named by their vertex letter unless there are two angles at the given vertex. And number 3, if so, refer to the angle using the 3 letters that will trace out that specified angle. So this is how to like notate, right? Proper notation for angles inside, like whether it's a triangle or just two lines, whatever it is. So we have some definitions for this unit, for this lesson specifically. Sorry, not unit. And you already have the definition sheet for for your for your unit. So please take a look at that. But here we have angles formed by two intersecting lines or line segments that meet at a vertex, labeled either by 3 capital letters with the vertex in the middle or by the vertex alone, and must place the angle symbol in front of the letter. So this could be notated in different ways. So if we have this angle here, right? This is the angle we're talking about here. We can call that, oh, that's angle B. Or we can call that, oh, that's angle CBA.
Exactly.
Or it doesn't have to be CBA. We can call it ABC. The order doesn't matter. What really matters here is that the corner, the vertex you're talking about, is the letter in the middle, right? The capital letter in the middle. So that's what you want to make sure when you notate your angles, right? You either use the angle itself, or if you have to use the other points, reference points here, making sure that the vertex of the angle you're talking about is the one in the middle. That's important here. Okay. So then, more definitions here. Interior angles, angles formed inside a polygon by two sides meeting at a vertex. So that would be this, this, and that, right? Pretty simple. Interior means inside in English, so the angle's inside a polygon. The exterior angles are angles formed at the vertex on an extended side of a polygon and an original side. So that would be the outsides here, and these angles would be considered exterior angles. Okay. Then we go through some theory or some rules, if you want to say it. Laws, rules, theorems. The first theorem, you've already learned this, the complementary angle theorem, called the CAT. Complementary angles add to
90 degrees.
90 degrees. Very simple. A right angle. Perfect. And supplementary angle theorem, the SAT. Supplementary angles add to, Merzel said it, 180 degrees. Easy. And you have your two examples here. It doesn't have to be two angles. Like I could draw multiple lines here. As long as all of them add to 90, it's still complementary, right? So it could be two or more angles that add to 90, two or more angles that add to 180. It's not restricted to two. The opposite angle theorem, we went over this at the beginning of the unit. Opposite angles are the same.
Equal.
Yes, slash
Equal.
equal. You can use the word equal as well. Yes. So what that means is A and C are equal, and D and B are equal. And Milana types 360. Yes, in this case, if we're looking at all of the angles here, they should total up to 360 because it's a full circle. Okay, so that is a good point as well to point out. But yes, the opposite angles theorem are just saying, hey, the angles opposite each other, right? A and C as well as D and B, they're equal to each other, right? As long as it's working with two lines. Then we have some examples here. Okay, so let's go over some of these examples. I'll pick all the odd ones, so we'll do 1, 3, and 5, and then you guys can do 2, 4, and 6. So for number 1, we determine the missing angles. Oh, that's a straight line. That's supplementary. And so we know that x plus 65 should equal 180. And we just solve for x. We do the basic algebra here, right? Addition becomes subtraction on the right side. We subtract 180 minus 65, like Elias said inside, and we get 125 is not correct.
You get 115.
And don't forget your degrees sign. So 115 degrees is going to be x. For number 3, the first thing you're going to do is say, oh, D is equal to 42. Why? Because of the OAT, the opposite angle theorem. So due to the OAT, we can say that D and 42 are equal. They're opposite angles of each other. So you don't have to write any other rules. So that's 42 degrees. Then there's a whole bunch of different ways you can solve this. You can either say, oh, I'm going to look at this line as my straight line, and that would make A and D supplementary, as well as C and 42. The other way you could do it is say, oh, I'm going to use this line as my supplementary line, which would mean A and 42 are supplementary and D and C are supplementary. Whatever you do, it doesn't really matter. I'm going to pick this line as my supplementary angle or a supplementary line. So these two are going to be supplementary angles. So we can say, oh, D plus A is equal to 180. And we know what D is, which is 42. So we can move 42 to the other side and it subtracts because it's adding. And we're going to get 180 minus 42, which gives me 138. So 138 degrees is going to be A, which should immediately show you that A is equal to C because they're opposite angles. So C is also equal to 138 degrees. Mercel said, I just do 360 minus 84 divided by 2. It's what I usually do. Absolutely, you can do that. The third option that Mercel is saying is that all four of these add up to 360. So you can just add 42 plus 42, subtract it from 360, and then divide it by 2 because A and C are the same. Yes, you can definitely do that. That works as well. So this is just me just kind of simply going step by step saying, oh, I can figure out D, then I can figure out A, and then A gives me C. That was my thought process. So as long as you fully show your work, I'm okay with it. Right? What matters is that you show your work. If you just write the answer, all I can say is you cheated. because, well, it kind of sucks because I can't see you in person, right? So please show your work. It helps me know that, hey, you actually put effort into it and you actually solved it and you're writing down your steps. It's proper math. I like that. I know you guys aren't cheaters. I believe in you. And number 5, we have what Milana said earlier was 360 degrees for a full circle. So we have 230 on one side, which means E plus 230 must equal 360. We can move 230 to the other side. And that's going to give me E. And so 360 minus 230 is going to give me 130 degrees. And that's going to be E. So, questions 2, 4, and 6. Please try these on your own right now. I'll give you 3 minutes, 1 minute for each question, and we'll take it up. Some of you might already even be done because you guys were working quickly. It's 3 minutes on the clock.
Sir, I'm done.
That's great. Just wait for everyone else to finish as well.
All right.
Okay, time is up. Does anyone want to give me the answer for number 2?
Yeah, I have an answer.
Okay, Sino, what's the answer?
So you should 62 plus 90, and it's going 152. 152 minus 180, it should be 38.
Are you doing question 2 or 4?
The 6.
Oh, you're doing 6.
Yeah, 6.
Oh, okay. So for question 6, what was F? What did you get for
The
F?
F is 152 minus 28.
And what did you get for G?
Yeah. G is
And G
19.
you said 90?
19.
Okay, good. And then, does everyone agree with that? For number 6, Sina's answers. F is 28 degrees, G is 90. Perfect. I saw Kuzli and Mersel do number 2, and they got X is equal to 38 degrees. Everyone agree with that? Absolutely. 38 plus 52 definitely equal 90. And here we have the 90 degrees here, which means G also has to be 90 degrees, like Sina said, right? And then with that, we can say 180 minus G minus 62 gives us F, because they're all on a straight line. Perfect. And that gives us 28. Very good. With that being said, last one, number 4. Elia wanted to do number 4. Elia, what did you get for D? And how did you get it? Perfect. So Elia did 38 plus 17 is equal to 55. And then for D, he said it's 180 minus 55. And Elia got 125 degrees. Everyone agree with that? Perfect. Everyone agrees. Looks good. Fantastic. Looks great. Okay. So looks like you guys are pretty good with angles. So let's keep going here. The next few theorems, the sum of interior angles is just adding all of the interior angles, and that should equal 180 degrees for a triangle. So adding all 3 angles inside of a triangle adds to 180. And for a quadrilateral, which is a 4-sided shape, any shape with 4 sides, it's always going to be 360. And it's written there, but any 4 angles inside a quadrilateral will always be 360. Okay, no matter what. The isosceles triangle theorem. In an isosceles triangle, the angles opposite to the sides are equal, so it's indicated here. We're saying that if these two are equal sides, this angle and this angle are the same. And for the equilateral triangle theorem, the equilateral triangle, each interior angle is equal to 60. So all 3 sides are the same, which means all 3 angles are the same. And that's going to be the ETT, the equilateral triangle theorem. Some of these you guys are probably like, oh, Mr. Choi, we know this. We're smart. I mean, yes, of course. I'm just reviewing. I know you guys are smart. So the next part here, exterior angles are formed by extending the sides of a polygon. The interior and exterior angles at a vertex of a polygon are supplementary. So A, B, and C are measures of exterior angles. So if we draw a triangle, right, how you would draw it would be like drawing a really long line and like making sure that you kind of go through. These would be like exterior angles here. Does that make sense? So notice how it's kind of odd the way you draw it. So the exterior angles, so A, B, and C in this situation would be called exterior angles. And then for a quadrilateral, looks kind of like this, looks a little weird, but all 4 of these angles, M and OP, would be called exterior angles. So outside angles of a polygon versus interior, which is inside angles. What really matters and what's really important about exterior angles is that this theorem, the sum of exterior angles, all angles outside the exterior angles, if you add them up for both triangles and quadrilaterals, it will always be 360 degrees, no matter what. It doesn't matter. If you add up all of the exterior angles, you're always going to get 360 degrees. Okay? You're always going to get 360 degrees. Now, what matters here, though, is how you target your exterior angles. Okay? And what matters is how you target them. So, first off, let's try these 2 questions here. Okay? So the first one here is an isosceles triangle. We have an isosceles triangle here. These 2 sides are the same, which means x is also equal to 52 degrees. These two angles have to be the same. This allows me to then use my interior angle rule for triangles, where we can say, 180, or we could say 52 plus 52 plus y is equal to 180. Adding all three angles inside the triangle equals 180. That gives me 104 plus y equals 180. So y equals 180 minus 104. I'm going to write that up here. So y would equal 76 degrees. So we have y is equal to 76 degrees. Any questions on this one? Not bad, right? Not to be confused, you're not solving for the capital letters. You're solving for this one here, this angle here. We'll call this theta. The Greek letter that we use to represent missing angles sometimes is theta. So I'm going to teach you this now. So we'll say theta is what we're solving for. The exterior angles are here, 140 and 120. And theta is also an exterior angle. So the rule is that all exterior angles add to 360. So my equation would be theta plus 140 plus 120 would equal 360. So theta plus 260 will equal 360. Theta equals 360 minus 260. So my final answer, theta is? Anyone?
100.
100. Thank you, James. 100 degrees. So theta is going to be 100 degrees, and we're done. All right? So that's the sum of exterior angles. Yes.
Can I say something?
Yep.
You say when you're doing math, symbols are very important, right?
Yes, sir.
If you don't have symbols, you're going to lose marks.
It depends on what you mean by symbols, though.
Like degree symbols. You don't put degree symbols for angles.
Yeah. You should always put degrees if you're talking about an angle. That is correct. Because it would be considered a unit, essentially. That's a really good question. That's a really good comment and question. Very good. Anyone else? Any other comments, questions? All right, no other comments and questions. Let's do one more here. Let's do the quadrilateral one down here. Let's do this one down here. So this one here, you need to find all of the missing values, right? Let's find all three of these. We should probably solve for x first. So if the first angle here is x, second angle 2x, third angle is 54, fourth angle is 3x.
So what is the 2x means?
It just means 2x. Right? 2 times x.
Oh, okay. All right.
And then once we have that down, okay, we can then solve for our the angles using our interior angle theorem. So for a quadrilateral, a four-sided shape, all the inside angles, the interior angles, add to 360. So we do x plus 2x plus 3x plus 54 is equal to 360. Then adding this, collecting like terms, x plus 2x plus 3x gives me 6x. And we get 6x plus 54 is equal to 360. And so we can finish solving this. 6x is equal to 360 minus 54. And we're going to get 6x is equal to 306. And then we can divide by 6 on both sides, which will give us x. That gives me 51 degrees as x, which means This is 51 degrees. 2x would be 102 degrees, and 3x would be 51 times 3, which is 153 degrees. And now we have our three angles. Okay? So notice how I'm solving for x first, then I can find all the other angles that are part of the quadrilateral like this. Okay? So there are 5 questions left here on this page. So I should give you more than 5 minutes because these are a little bit longer. So let's give you, we love 8 minutes. So we'll give you until 2:40 to try these questions. 2:40. So 8 minutes, try giving these questions a shot. So you have the top right, middle left, and then the bottom 2. So give the rest of these questions a shot, and then we'll take them up as a class. Okay, you should be done. So let's take up our work here. Does anyone have the answer for whoops, that's not how I want to do it. Anyone have the answer for this top right one here? What is x? This one here, this 90 degrees. All the exterior angles add to 360. So we do 125 plus 95 plus 90 plus x is equal to 360. And when we add that all up, 125 plus 95 plus 90 gives me 310. We move 310 to the other side, making it subtract. And we're going to get x is equal to 50 degrees. And you should have gotten 50 degrees for this one here. For this left triangle, anyone solve for this one?
I have a question for that one, last one.
Yeah.
So how you get the 310?
Adding this, and this.
So why you didn't add the x?
I did. It's up here.
Oh, okay. Yeah. Okay.
Right. All four of those add to 360.
Yeah.
Does anyone have the answer for x here?
You mean the interior angle?
Yes. And Mercel said 28 degrees. Does someone want to verify that? Are we good?
All angles in a triangle lead up to 180.
Yes. So if you subtract 180 minus 69 minus 73, I don't get 28. I get 38. That's my angle. Can someone want to confirm that? 38 degrees, yes?
Totally.
Yes, 38 degrees. All right. Then we have this middle one, which is a lot. I'm going to zoom in a little more so I have a little more space to work with here. So the first thing we can solve for right away is z. Z's easy. That's 35 degrees. Boom, bada bing, bada boom. Easy. Because they're opposite angles, right? So z is 35 degrees because they're opposite angles. Then you can actually solve for x next. It's actually the easier one. You can notice that this here is a triangle. As a result, you have 90 degrees and 35 degrees. So we can also say that, let's do it up here, for example. Let's x plus 35 plus 90 is equal to 180. The interior angles of that triangle. Okay? In doing so, we can solve for x, which is going to give me 125 is equal to 180. We move the 125 to the other side and subtract, and we're going to get 55 degrees for x. Okay, we get x is equal to 55 degrees. Then our last one for y and 60 are complementary angles. They add to 90 degrees. So y plus 60 makes 90 degrees. And so solving that out, y is equal to 90 degrees minus 60 degrees. And that's going to give me 30 degrees as my answer. Are there any questions for this middle one? Now, does it matter that I solve for z first? No, you can solve in whatever order you want as long as you have all of them. It might look like it, right? Don't go from what it looks like. It's not going to be the most accurate drawing every time.
Always find out the exacta
Yeah.
one.
Just use the numbers that the questions give you. I know that
No.
sometimes it's like 45 degrees and stuff, but Mercil, yeah, just use the numbers that they give you to solve for the exact values there. Okay? All right. So, the last two questions here. So, this one here, you're solving for angle TPQ, UQR. Oh, it got cut off here. Shoot. That's probably YRS, and then WSP. Okay. So there's all the exterior angles you're solving for. So remember, all exterior angles add to 360. So on the side here, we can say, oh, x minus 5 plus x plus 4 plus x plus 7 plus x minus 10 is equal to 360. Well, that takes up a lot of space. We break the brackets. So we're going to spend time breaking brackets here just in case we don't mess up. Collecting like terms, that's 4x's. And then negative 5 plus 4 plus 7 minus 10.
It's so confused.
I know, it's a lot. But negative 5 plus 4 is negative 1. Plus 7 is positive 6. Minus 10 is negative 4. So you should be able to simplify this to 4x minus 4 equals 360. Oops. Like that. So you should be able to get to this point here. Moving the minus 4 to the other side, 4x is equal to 360 plus 4. And then we divide by 4 on both sides. And that's going to give me x is equal to 364 divided by 4, which is 91 degrees for x. So for x, we get 91 degrees. And we're going to use that to solve for all of our angles. So for angle, let's write each one. So angle TPQ is equal to x minus 5, which is equal to 91 minus 5. So that's going to be 86. So that's the first one done. Angle UQR is equal to x plus 4, which is 91 plus 4, which gives me 95 degrees. Not forgetting the degree sign. So angle UQR. There's our second angle. Our next angle would be YRS, which is x minus 10. So 91 minus 10 would give me 81. So that's angle YRS, 81 degrees. And our final one is angle WSP, which is x plus 7. So 91 plus 7 is going to give me 98 degrees for angle WSP. Are there any questions for this one? I know this looks really complicated. It's just long. It's not hard, right? You're just collecting like terms. So just take it slow when you collect like terms, and it should become a lot easier to remember and solve. Okay. Anyone else with any questions? All right, looks like there's no questions. Our last example problem that I asked you to do was this one, which is looks a lot simpler than the previous. So for this one here, it doesn't matter what you solve for, whether it's y or x. I'm going to solve for x first. So for x, I could say, 29 plus x is equal to 180 because they are supplementary angles. And moving the 29 to the other side, I get x is equal to 151 degrees. And then for y, it's the sum of interior angles of a triangle. All three angles add to 180. So y plus 29 plus 52 is equal to 180. And we're going to get y plus 81. Or no, 80, yeah, 81 is equal to 180. And subtracting that out on the other side, I'm going to get y is equal to 99, sorry, not 91, 99 degrees as y. So looks like Mersel answered the question, 99 degrees and 151 degrees. Can I zoom out? Yes, I can zoom out after I'm done. So we have 99 degrees for y and 151 degrees for x. So I will zoom out now so that you can see everything as a whole. Are there any questions about this section here? It's a lot. I know it's a lot, but it's making sure you understand all of the angle theories.
This is great. Just great.
Okay. So some of you are probably feeling very, very much more confident in this unit than the previous units, which is great. That's what we want, right? This unit is something that's more using your previous knowledge, because like unit 3 wasn't really previous knowledge, so that was new stuff for grade 9. So you should feel a little more comfortable with these questions, right? Just a little bit more than the previous unit. All right, let's finish off today's lesson. The exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So in specific here, you'll notice in the diagram, angle 3 is equal to angle 1 and 2. So the exterior angle is equal to the opposite interior angles of the polygon, or of the triangle here. Okay. And this is just another example here. The exterior angle is the sum of the two interior angles that are not touching that vertex. So angle A plus angle B is actually equal to the exterior angle on angle C. Okay. Logically, this makes sense. Because if angle C here, I'll call this alpha. If alpha plus this red angle here are supplementary and they add to 180, then these three angles inside also add to 180. Then if you subtract alpha, you're left with the two angles equals the outside. Logically, it makes sense, but we're just kind of listing it out here as a rule, which is the exterior angle theorem. Okay. This allows you to solve questions that you thought were not possible before. So for example, let's go through each one of these. We have to find angle X out here. We're given 50 and 60. And using the exterior angle theorem, we can say, oh, that's easy. 50 plus 60 is equal to X. And we're already done our question. 110 degrees is equal to X. Okay. Even questions like this, where you're like, wait.
Can I say something?
Yeah.
So you should so it's gonna be 110 minus 180.
If you wanted to find the inside, yes. But it's solving
No,
the outside.
if you want to find the outside X.
No, the outside X is 110.
So how about inside?
I never asked for inside.
Oh,
But if you want to find the inside, you would do 180 minus 110. Yes, that's correct.
oh, I thought it's inside.
It's outside here. See this, right?
Yeah.
Outside. So for this one here, we're solving for angle S, which is on the inside, the interior angle S. But we know the rule here, S plus 90, because square angles mean 90 degrees, is equal to 144, the exterior angle. So these are the two interior on the other vertices. And so we can move the 90 to the other side. And that's going to give me 144 minus 90, which gives me 54 degrees for S. Okay, so S is going to be 54 degrees. This final one here, notice how you're not really given angles here, but you need to find all of them. Sure, this is a letter D. So what we can say is, well, angle B and D are opposite of the exterior angle of angle C here, right? ECB. So let's solve for our equation. Let's set up our equation. We're going to get x plus x minus 1 is equal to x plus 35. So that setup is this plus that is equal to this. That's what the exterior angle theorem is. You should be able to simplify that to 2x minus 1 is equal to x plus 35. We now have x's on two sides of the equation. We don't like that. If you think back to unit 1, we said, let's move x to the left and let's move all numbers and other terms to the right. So positives become negatives and negatives become positives. So this is going to be 2x minus x is equal to 35 plus 1. And that's going to give me x is equal to 36 degrees. Okay. We're not done. So once we have that, we can say, oh, that means angle B is equal to 36 degrees because it asks for the missing angles. That means angle ECB is equal to x plus 35. We know what x is now, so we can plug that in. So angle ECB is equal to 71 degrees, 36 plus 35. And our last one, angle D, which is x minus 1, which is 36 minus 1. So angle D is going to be equal to 35 degrees. And there's our final answer for that one. So you want to make sure you state, if it asks for missing angles, notice how I don't say, hey, solve for x. You got to read the question carefully. If you just solve for x, you lose some marks, right? The question specifically asks for finding all the missing angles. Solving x was the first half of the question, and you needed to use that to solve for the missing angles, right? By plugging it into their algebraic expressions. So making sure you explicitly state each of those angles is crucial. Okay? Are there any questions about today's lesson?
No.
All right. Then if there are no questions about today's lesson, you have some homework stuff here. It's all triangle stuff. So give these questions a shot. The answers are at the bottom. And tomorrow we'll be working on 4.6, and the lesson will be uploaded in the morning. And tomorrow's lesson should be, I think, shorter than today's, to be honest with you. But we'll see. So otherwise, have yourselves a wonderful rest of the day, and I'll see you tomorrow, 2 p.m. All right? I'll see everyone tomorrow, 2 p.m.
Have a great day. Bye.
You too. Take care, Sina.